the standard normal distribution. The standard normal distribution has a mean of 0, it has a variance of 1 and a standard deviation of 1, and it's very useful for problem solving. And we use it like this. So you start off with a problem where a mean or a standard deviation perhaps is unknown, and because one of these or both of these are unknown, you can't use your calculator's built-in statistical function here. You need both of these values to do any calculations. If either one of them or both of them are unknown, your calculator is not going to be of much use. So we take the original distribution represented by the random variable x, and it undergoes a bit of coding. So I've taken my original data, I've subtracted the mean, and I've divided by the standard deviation, which gives me my standard normal variable z. And the distribution for z is well understood. We have the mean and we have its standard deviation and variance. So if there are any calculations to do in the original distribution here, and we can't do them because one of these is unknown, we can apply this formula and change to the standard normal variable and do any calculation we like using this. To get a better understanding of this standardizing formula, I'm going to show you an example using coding. Now you don't need to know this for exam purposes, but it may help to understand the topic better. So I've got some data x. Here are the data values. The mean for this data is 40 and its standard deviation is 4. So I code the data, so I subtract 40, the mean, from all of these data values to get these new values. So these are coded values, and the mean of these coded values is now 0, and the measure of spread, the standard deviation, is unchanged, it's still 4. Now I divide all of these values here in blue, I divide them all by the original standard deviation. So now I've got these values. So the mean is 0, the standard deviation changes this time, it's now equal to 1. Again, you can put all of these numbers into your calculator and you can verify the mean and standard deviation at each step. If I remove the middle stage here, what we've done in the coding is to subtract the mean, so original data minus the mean, and then I divided by the standard deviation. I don't really need this data here to continue with, so now if my data is normally distributed, I need some values to put in here. So I need a mean and a variance, which will come from here, squaring the standard deviation, and same here. So we get these values. Now this looks familiar. A mean of 0, a variance of 1, and a standard deviation of 1. This is basically the standard normal variable z. If I now replace 40 here and here with just the symbol for the mean, because 40 was the mean, we're just generalizing now, so we get this. And then I'm going to replace the 4 here and here with the standard deviation, again just generalizing, so now we have this. So to go from any normal distribution to the standard normal distribution, we have to apply this formula, which is called the standardizing formula, which brings me back to this original slide. Now we have a sketch separate here for the original normal distribution, and this one here for the standard normal distribution. What I typically do is do a single sketch, and I just put a separate scale here for the original variable and the standard normal variable. So the original variable has some mean here. For the standard normal variable, we know the mean is 0. This is just for convenience, most just stick to separate sketches.